Embark on a journey of inspiration and discovery with the Purdue Lecture Hall series, proudly presented by the Purdue Institute of Inflammation, Immunology, and Infectious Disease. Join us as we delve into the remarkable odysseys of these aspiring scientists, each crafting their own narrative in the world of science and groundbreaking research. Take a glimpse into their diverse cultural backgrounds and the journeys that brought them to Purdue University. Thank you for watching the Purdue Lecture Hall series. Remember to hit the like button and subscribe to our channel. Welcome, everybody. My name is Tommy Soares. I'm Director of Scientific Strategy and Relations for the Purdue Institute of Inflammation, Immunology, and Infectious Disease. And today on the Purdue Lecture Hall series, I have the pleasure of welcoming Paul Oladele, who is a Ph.D. candidate in the Department of Animal Sciences at Purdue University and is pioneering the development of microbiome-based strategies to enhance animal health with a particular focus on improving piglet well-being during the crucial weaning period. His innovative research is crucial in the quest to find sustainable alternatives to antibiotics, aiming to mitigate the rise of antibiotic-resistant bacteria, a significant concern for both animal and human health. By leveraging computational analyses alongside in-depth in vitro and in vivo studies, Paul is at the forefront of identifying microbiome modulations that can protect piglets from enteric infections during the vulnerable phase. In addition to his groundbreaking research, Paul plays a vital role in the academic community as a mentor to undergraduate students, fostering an environment for growth and collaboration. His commitment to the future of animal sciences extends through his participation as a fellow of the Foundation for Food and Agriculture Research, the FFAR, where he engages in professional development programs with a diverse group of graduate students from the United States and Canada. Through his work, Paul is not only contributing to the advancement of sustainable agricultural practices, but also preparing for the next generation of scientists to tackle the challenges of global food security. His efforts reflect a dedicated pursuit of solutions that promise to improve animal health and production in the post-antibiotic era. I am so excited to have you on the program, Paul. It's great to be able to touch base with you and hear your story. Thank you for taking time to talk to us.
Thank you, Dr. Soares, for that introduction. I must say I'm flattered.
It's absolutely very exciting, and I know you've been really dedicated to this field. I don't want to take a minute away from your presentation, so as we typically do, I'll let you take the stage. I'll put myself off and put myself on mute and let you take the spotlight.
Okay, I will go ahead and share my slide.
Perfect.
Can
Looks good. Yep.
Okay, I think I'm waiting for it to pop up on my hand. Okay. Oh.
So you might want to just do the swap. There we go. We got it. Full mode. Yep.
Full mode at the beginning.
Go for it, Paul.
Thank you so much, Dr. Soares, once again for that introduction and for having me on this lecture series. I'm really excited to share my background, my journey, and my research, and what I see in the future. I will try and okay, I think I have it now. Right. So let me give you a brief. Let me give a brief background about myself. I'm from Nigeria. Nigeria is in Western Africa. If you look at this map of Africa, Nigeria is here. This is a couple of Nigeria. We have Benin. We are bordered by Benin to the west, and we are bordered by Cameroon on the east, Chad and Niger on the northern side, and the Atlantic Ocean on the southern part. Precisely in Nigeria, I'm from the southwest part of Nigeria. I'm from Ogbomoso. Ogbomoso is here on the map here. One of the most popular places that everybody know in Nigeria is Lagos, and Ogbomoso is just a little bit up north of Lagos. One fun fact about Nigeria is that most people in Nigeria stay in the city. Lagos is like 20 million people. Ibadan has about 2 million people, and Ogbomoso is just less than 1 million people. So most of my early education was in Ogbomoso town. So I would give a bit of background about my educational journey. But just let's talk about Nigeria first. Nigeria is a beautiful country. Like Nigeria is really, really beautiful. We can see some awesome terrain here in Nigeria. This is like a waterfall. This is like a teak plantation, and this is just like a terrain of Lagos, Nigeria. So Nigeria is really beautiful. One other fun thing about Nigeria is that we mostly have two kind of seasons. Unlike America, we have when it's raining and when it doesn't rain. And so Nigeria is, we don't have snow or like any very cold weather. If you talk about the culture of Nigeria, we have more than 230 tribes in Nigeria, more than 230 tribes and languages in Nigeria. But those tribes, we have just three basic ones. The three basic ones are the Hausas, who are mostly in the north. So on this left-hand side, you have the Hausa tribe. We also have the Igbos. The Igbos are in southeastern Nigeria. And the last tribe is, we have the Yorubas, and I'm Yoruba. We are from the southwest part of Nigeria. Like I said, most of my early education was in Ogbomoso, my hometown. And so what the education system in Nigeria is a little bit different from the American system. So what you have as elementary school is called primary school in Nigeria. And what in America, what is middle school and high school is what we have as secondary school. Although in secondary school is also divided like middle school and high school. So I attended Federal Government College, Ogbomoso, for my secondary school, which is equivalent to middle school and high school. And it also has a primary school, which is equivalent to elementary school. So all of those period, elementary to high school, was in this same compound of Federal Government College Ogbomoso. And this school is run by the federal government. It is called Unity School, and there are about 104 of these colleges in Nigeria. So I attended one of this. So from here, I moved to for my undergraduate. So my undergraduate was also in my hometown, and I had that at Ladoke Akintola University of Technology in Ogbomoso. And this is just a picture of what Ladoke Akintola University of Technology in Nigeria looks like. This is the area view of the school, and this is the entrance. I still have fond memory of this place. This was my own college, the College of Agriculture, and my department was in one of this building. I still have a fond memory of this school because I spent 5 years of the time I was actually getting to learn and understand what it means to do research. So in Nigeria, you come in for a course, but we don't do much research for the first 4 years of the 5 years. So you have a final project that would be more like a thesis for your final project. So for my final project, I was in the Department of Animal Production and Health, and my final project, I had the opportunity of working with this professor, Professor Oladele, who I would say in my journey of understanding research, he was probably the most influential. He has probably still been the most influential because it gave me the first introduction to doing like real research. And so for my undergraduate research at Ladoke Akintola University of Technology, which we almost usually call LAUTECH, I worked with this professor. He was a physiologist. He does things from reproductive physiology to just eat stress physiology. So I use rabbit for my research, and just given an example of this, I still remember this research very well. We were trying to use alternative ingredients to feed rabbit and check the effect that one of those alternative ingredients is cotton seed. And cottonseed has this poisonous, this antitoxic, this toxic compound called gossypol. And so gossypol usually affects the reproductive health of even humans or animals. So my research was trying to understand the impact that gossypol from cottonseed cake has on the male reproductive physiology in rabbits. And this was my first real introduction. This man was very patient with me, trying to teaching me the ropes of integrity in doing research, the rigor in doing research, giving me the things that, okay, you want to design experiments, do it this way, do it this way, do it this way. So that was my first real introduction into research. And one other interesting thing I have to say at this point is that initially when I was coming to do my final year research, I wasn't really interested in doing reproductive physiology. My goal was to do genetic research. But when I was assigned to this professor, I just fell in love with his character, the way he mentored, and it was a great experience. From here, I moved to the University of Ibadan, and I eventually worked with a geneticist. Dr. Mabel Akinyemi was my advisor when I was in at the University of Ibadan. And I remember then we will go out and what we wanted to know here was what was the genetic basis of animals being resilient or not being resilient to heat stress. Like specifically, we were looking at goats. And so the Nigerian indigenous goat, we have a couple of indigenous goat breeds. So we're looking at some of these goat breeds and trying to check what makes some of them to be resilient to heat stress and some of them not to be resilient to heat stress. And that was also a fun time. But after I finished this, I had a master's in the University of Ibadan. And after I finished this master's, I decided that I wasn't sure I found exactly what I wanted to do. Remember, I wanted to do genetics before. I did physiology and then I did genetics. And I was like, I'm not sure if I have gotten everything I wanted to do. So I paused and I went to work a little bit. And from working, I worked in nutrition, in the nutrition sector. I actually co-founded a nutrition company. And from there, I was trying to understand what is the nutritional basis of some of the ingredients that we had, and how were they interfacing with human health. And also a similar way of interfacing with animal health. And because I had an animal health background, I reached out to, that was what was the basis of me coming to America. And also my journey to Purdue. So I came because I wanted to know how nutrition interfaces with both animal and human health. And so I traveled all over the Atlantic Ocean to come here to Purdue University. And I came to the lab of Dr. Kola Oladele, who was very gracious in accepting me to his lab and actually giving me more in-depth understanding of molecular analysis and nutritional physiology, how molecular biology interfaces with nutrition, specifically animal nutrition. And interestingly, I had not so much background in nutrition. And so I was coming with a little bit of background in physiology, a bit of background in genetics, but nothing in nutrition. And so from here, I caught the understanding of nutrition and molecular biology in depth. But one other interesting thing that happened was that this was also the time I got introduced to microbial ecology, microbiome science. And these are the people in the wonderful lab that I work with. So I worked with pigs at this time to understand how the different diet I would give to pigs kind of help them with coping with heat stress. Now, around this time also was when I met Dr. Tim Johnson. Now that's a very interesting story because Dr. Tim Johnson was in my committee for my master's I did with Dr. Wajomo. And he was the one that was helping me with understand the microbial ecology part of my research. Now, interestingly, that microbial ecology will end up becoming the major focus of my research for my PhD. So after finishing my PhD, I had been in contact. I had been working with Dr. Johnson for about 2 years. I was learning so much about microbial ecology. And so when I finished, I reached out to him that, I'm getting interested in doing more microbiome science. And understanding how it interfaces with animal health. And I was like, oh, I have a project that you can do. And I was like, okay, that was why I joined his lab. And these are like the wonderful, I've worked with so many awesome people in the Johnson lab. And these are just some picture of the people who I've worked with in Johnson lab. Now, let's come to the nitty-gritty of my research in Dr. Johnson's lab. And most of what I do in Dr. Johnson's lab has been about harnessing the power of the microbiome to reduce antibiotic use and improve animal health. And specifically, a lot of my research has been focused on pig, although I've worked with other species. I've worked with the microbiome in turkey and chicken, and also even in ruminants. So the major issue that I was trying to answer, that I'm trying to answer for my PhDs, is the fact that during weaning, just like even human babies, pig go through a lot of stress. So they have a lot of physiological stress, nutritional stress, and environmental stress. This stress often leads to dysbiosis of the gut microbiome. And I can take a little bit of introduction to just say the microbiome is just saying the diverse, the complex microbes in terms of bacteria, fungi, viruses that live together. In this case, specifically in the gut. The microbiome is not limited to gut, but for my own research, I'm looking at the microbiome in the gut. So when pigs are stressed, it often leads to dysbiosis, which is disruption of the microbiome condition of the pig, which is usually characterized by a decrease in diversity. And this often leads to the proliferation of a pathogenic strain of E. coli, enterotoxigenic E. coli, particularly two strains are most common, strain F18 and F4. And so these proliferation often cause diarrhea in the pigs. So the solution to this diarrhea in pigs is that we use antibiotics. So antibiotics is the most widely used. And in short, antibiotics are really effective in preventing post-weaning stress, post-weaning diarrhea, and everything that comes with it. The challenge with antibiotic use is that antibiotics is also increasing antimicrobial resistance. It's increasing resistant bugs. And we know that the resistant bacteria that comes from animal system is not limited to animal system. It can flow into the environment whereby it can interface with even human. And human pathogen can also pick resistant gene from animal microbes, animal pathogen. And so this issue of antimicrobial resistance is a major public health concern, not just for the animal industry, but for human. I can give you an example. C. difficile diarrhea is a major problem in for human health. And also some of the antibiotics that we use for surgery, for even immunotherapy, use antibiotics a lot. So this issue of antibiotics resistance is a major problem for a major challenge facing human health. So we need to reduce antimicrobial use even in animal because of the possible danger it has to animal health, animal production, and even to human system. It's a major public health problem. This is from some of my own even previous research on trying to do and to track antimicrobial resistance when we use antibiotics in animal system. And this is just a system whereby we use antibiotics, 2 levels of antibiotics, and we use them for a period of 78 days. This is in turkey though. And you can see that the 7 antibiotics is increasing. But when you get to day 35, you can see a massive spike in antimicrobial resistance. This is exactly what we don't want. The other problem is that these antibiotics are not even existing in vacuum. They are also living with some things that we call mobile genetic elements. And so they have a level of interaction with mobile genetic element here. And the problem is when antibiotics itself is a problem. But when antibiotics even exist with mobile genetic elements, it's even a massive problem because it means that bacteria can keep on exchanging antibiotic resistant gene when they are associated with mobile element. Because mobile element, unlike human beings that we don't exchange a lot of genetic material, bacteria are not like that. They can easily exchange genetic material. And when mobile genetic element, they facilitate this exchange of genetic material. What it means is that if a bug has resistance, even though it's not pathogenic, it has a possibility of exchanging this gene with with a pathogenic bacteria. And if you exchange that, that is be a massive problem because the pathogenic bacteria can then acquire resistance and be resistant to different antibiotics. One other thing is that antimicrobial use in animal system, even in human, doesn't cause resistance to that particular antibiotics. It can cause resistance to even more antibiotics that they were not exposed to. So that kind of makes the issue of antimicrobial resistance a major problem. And so in pig, coming back to the pig microbiome that we were talking about earlier, and so the microbiome of pigs kind of evolve in a particular over time, like it matures over time. And this is an example of the lactation microbiome of a pig, the lactation stage of a pig. This is the microbiome. This is the weaning period, and this is the weaning period, and this is the growing period. And if you look at it here, you see the microbiome around weaning transitioning to the growing period here. This weaning period microbiome is a major period whereby pigs are under a lot of trouble, a lot of gastrointestinal problem because they're changing diet, they're changing a lot of things. However, once they mature to the grower period, the microbiome is mostly, the pigs mostly overcome this microbiome problem. And once they overcome, they become healthy. The question is that this weaning period that the microbiome is not in good shape, can we mature the microbiome and jumpstart it to this growing microbiome? In essence, can we hasten the development trajectory of the microbiome and move it from this period, this problematic period, when we use a lot of antibiotics, and mature it faster to this grower period, whereby they don't need to use so much antibiotics? That's exactly what we're trying to do. And this is like a proof of concept of somebody that some of the earlier research have done that. And you can see this is the microbiome of a pig that is having post-weaning diarrhea here in red. And this is the microbiome of a pig that is healthy. And you can see the one that had a form of microbiome therapy, which is called FMT, whereby you transfer whole community. And this is showing that we can move the microbiome from here to this place, which is the microbiome of the healthy pigs. And so the bulk of my work in the Johnson lab is trying to develop some of this kind of therapy for piglets. And traditionally, the way that we study bacteria is usually through culturing. And so we have plates whereby we streak different plates to maybe isolate different bacteria, grow them in culture, here in liquid culture, or even sometimes grow even maybe isolated bacterial community of bacteria in anaerobic chamber, because we know that the condition of the gut is mostly anaerobic. And so when we want to grow back this bacteria, and we don't want the anaerobic ones to die, we can grow them in anaerobic chamber, which is just a compartment that doesn't have exposure to, there's no oxygen there. Basically, that's what that is. And so so in the Johnson lab, we don't do just the traditional way of culturing. We also have this next generation sequencing to study bacteria. Now, so remember what I said, the traditional way of studying bacteria is through the culturing method. But there's a limitation to the traditional culturing method of studying bacteria, because we do know that a vast majority of bacteria that lives around us in the gut, in the environment, we have not been able to culture them. We don't even know the condition that is optimal for culturing them. And that's the problem. So to be able to study some of the bacteria that we cannot culture, to overcome that limitation is what next generation sequencing comes into it. And the way next generation sequencing to study bacteria works is just that we get the genetic material in the bacteria. This is the genome. So this is like an example of a bacteria. It has this genetic material in red inside of it. And we can take the genetic material, we can get them out, shred them into pieces, and then understand the genetic material, how those genetic material, what they look like, to understand what is in the bacteria. So in the Johnson lab, we use a combination of culturing and next generation sequencing. Although we focus more on next generation sequencing, but in my own research, I also do a lot of culturing and doing a lot of animal study, in vivo animal study. And so when we come to next generation sequencing, we use two major methods for studying bacteria with next generation sequencing. And I'll give you an example here. So we have a situation whereby we can take all the genetic material in the bacteria, shred it into pieces, and sequence everything to get what is the function, what does it look like, and we get this here. We can also do a more simplified method whereby we get all the genetic material in the bacteria. We look at a particular region that is common to all those bacteria, and we sequence just those portions, those very small fragments of DNA, and we use it to understand what is in the bacteria. Remember what I said here. We're sequencing everything the bacteria has. Here, we're just sequencing a small portion of what the bacteria has. And so the information we get from those two kind of approaches are a little bit different. And I would liken this to, if you look at this picture here, you can see that there is a house here, there is a lot of things here. So it can give you a snapshot of who is there, what is that thing doing. However, there's some of the information that we might not get when we do this kind of approach, this targeted amplicon approach, whereby we sequence a particular fragment of the DNA. What of this? If you look at this image, this same image is what we have just zoomed to know that, oh, there is a house here. The color of the roof is brown. The house has a tree in front of it. It has windows. And that's what exactly this metagenomic sequencing looks like. So here we have 16S amplicon sequencing. Here we have the metagenomic sequencing. So in short, what you can just say is that when you look at metagenomic sequencing, you can zoom in and have more information, more understanding of what is going on in the bacteria, either in the bacterial community itself. So we use a combination of this method. So we use both culturing in vitro, and we use sequencing, computational sequencing. This one has a lot of computation whereby you shred DNA into pieces, you sequence them, and then you have to stitch them back using computational approach. So I've said this is the way we do it. The question is now, what exactly do we do? So for my work, some of the things that I do is that we know that a pig is having gastrointestinal problem, is having diarrhea, is having post-weaning stress. But we know that there is a community of a healthy pig that is good. So we take this community that is healthy from the feces and transfer it into a pig that is having post-weaning diarrhea to improve their health. And we then come back and try to understand what stays in the animal, what doesn't stay in the animal, what improves the animal, what doesn't improve the animal. And I'm going to talk a bit more in depth about this more. And so this is an example of what we did. And so this is the pig that was a donor that we took the material from. These are the pigs that are weaned, that have undergone this post-weaning stress. And so you have, we had 3 treatments. We transferred the microbiome into the pigs through the oral route, through the rectal route, and the feed of the animals. And so the initial on day 0, when we had not done anything, this is the donor is different from the treatment groups. And then, let me just give an idea of what this is. This is a principal coordinate analysis plot. And what this is saying is that these dots that are close to each other are similar. The ones that are far from each other, they're just distant from each other. And so you can see the donor is completely different from these other ones. However, when we transfer these microbes, on day 2, they are still different from each other. On day 3, you start seeing that the treatment groups, the ones that got oral, rectal, and feed, they start moving towards the control. But you still see the control that did not get any microbiome therapy is still lagging behind in its microbiome. And you can see on day 7, the microbes still keep on moving towards the donor. Although they have not completely approached the donor, but you can see that they are actually moving towards the donor. Now, what this is telling us is that if we take a specific microbiome that we want, we can actually introduce into the pigs and try to exert the kind of change that we want in the microbiome of that pig. So we can be intentional about modifying the microbiome of pigs. And if we can do this, the question is, can we do it to introduce the same different phenotypes that we want? Yes, we can. We can use the microbiome to alter, we can use the microbiome, we can introduce microbiome to alter the community of an animal and exert the phenotype we want. For example, we use the microbiome, we introduce microbiome, the microbiome change, and the animal's daily gain, like the rate at which they grow, increases. The rate at which the animal is efficient with feed. We can also improve that with just transferring different microbiome into that pig. So this is just saying that when we modify the microbiome, not only can we change the microbiome, we can actually drive beneficial phenotypes, important phenotypes that we are interested in. We can actually drive it by altering the microbiome, which is kind of very powerful. Instead of using antibiotics during weaning, using a lot of antibiotics that causes resistance, we can actually take the microbiome, look at this is the phenotype we want, and kind of take the microbiome and put it to drive the phenotype that we want. So in summary, that this, other thing I've been saying is that we can take the microbiome, we can introduce it into a pig or any other animal to drive the phenotype that we want. And in this case, in my own research, I've only been focusing on trying to understand the microbiome, using the microbiome to improve post-weaning syndrome, post-weaning stress, post-weaning dysbiosis in pigs. This is not the limit of it. I'm giving an example of here that we have microbiome therapy can be used for so many different things in both animals and human. For example, I've used it for production, improving, reducing disease susceptibility and improving productivity in animals. We can also use for other different gastrointestinal tract disease in animals. Also for things like methane emission, we can use the microbiome. We can get microbiome that are more efficient in not producing methane, and introduce it into an animal and use it to alter the microbiome of an animal to reduce the emission of the production of methane. And also in human microbiome, approaches to modify, to improve health, to modify communities is very important. An example is, I mentioned Clostridium difficile earlier. This is a very major breakthrough in microbiome therapy, whereby microbiome is introduced into human, and it's more efficient than antibiotics. For C. difficile is a recurring disease. And so when humans have C. difficile infection, they use antibiotics. The C. difficile goes down a little bit, but reoccurs and keeps on reoccurring. And this is a very major problem for people who have this C. difficile infection. And so the interesting side of it is that when people use antibiotics for C. difficile infection, the remission is about 40%. But when we use microbiome therapy for C. difficile, it's like 90%. It's like double, even more than double of clinical remission. So that kind of shows you how powerful the microbiome is in improving health. So other people have also been targeting the microbiome to improve human health for cases like inflammatory bowel disease, like Crohn's disease, and also even neurodegenerative disease. There's a lot of focus on trying to see how the microbiome can be used to improve things like Alzheimer's, like Parkinson's, and the rest. And all of this kind of shows you how powerful, how important the microbiome is to improve health. And just coming to some of the things that I've personally learned, I think oftentimes since I've been talking since, I haven't. I hope that there have been a couple of lessons that we can learn from it. But one of the biggest things I would say is that it is absolutely important to have a strong community in science. And science, I always say this, that science is best done in the community. Like science done in isolation, science is hard enough. It's harder to do science in isolation. And so for me, one of the things I also do is trying to help get a community around me, kind of help other people to do research better, trying to work with different people. And so I had this fantastic opportunity of working with of attending this microbial diversity course at the Marine Biology Laboratory. And here we had like a different graduate student and PhDs and postdocs from different countries. We had people come from Germany and the rest. And what we are learning is just an intense period of learning things about microbial ecology for just about 5 weeks. And here, this was my cohort. I'm still in contact with a lot of people from this cohort, people that we have never met, but we became a community of microbiome scientists. And this was the project I had. This is kind of fun and this is kind of fascinating because at this point I was a gut microbiome person. and I was interested in trying to do something else. So I tried to do environmental microbiome. And this was the setup that I had to isolate bacteria that can conduct electricity. And this is kind of completely different for me. I've been about health and health and health, but this is just about trying to use microbiome for some more sustainable energy production. And so I was trying to design microbial fuel cell to isolate microbes that can conduct electricity. And here you see this chain of blue ring bacteria here. And these are just cable bacteria. So these bacteria can form like long chain and conduct electricity. And the fun thing is I was trying to isolate this bacteria, even though I could not get a single isolate strain, but at least I could enrich for this bacteria. This bacteria has never been cultured before. So I was very close to getting like an isolate of this bacteria. And one thing I'll just say is here is that in trying to do science, it's important not to be afraid of going beyond one's comfort. Like, never be afraid to step out of your comfort and try what you don't know before. It is in doing what you don't know before that you actually learn to do something new, something different, something fun, something fantastic. So this was an exciting opportunity, even though at the beginning it was hard. At the beginning, I had no idea what I was doing, but it was important. It was an immense opportunity for me to grow and acquire different skills. So I would say that as many opportunities that you get to try different things, to attend courses, attend programs, learn different skill set that you probably cannot learn in your degree. For PhD students, that is going to be absolutely vital. And I also say from my own journey, I also learned something that from the beginning, I started from physiology, went to genetics, came to microbiome science, and I'm combining almost everything now. It's okay not to know what you're doing. It's okay not to know what you want to do. But as the time goes on, just be diligent, do what you have to do at a point, and you figure out what exactly interests you, what exactly you like to do. And I have these also as I know Dr. Saul mentioned this earlier about my involvement with the Foundation for Food and Agriculture Research. And this is just a fellowship that I also have with different PhD students from different parts of the United States and Canada. And most of this is just professional development, trying to get the things that we don't get in the PhD about personal development, professional development, how do you do things. And so this is what I do for my in this fellowship. And I get the chance to work with different PhD students, work with different people, get involved in mentoring, get involved with how the industry works, what is life out of academia, how do we spread the news of research that we do. So I will say that this kind of opportunities is very important. As PhD students that we are very immersed, as graduate students that we immersed in the daily integrity of doing awesome science, which I know awesome science has been done, but it's also very important that we are able to get involved in opportunities that can build us and build other people around us. And I think this is probably towards the end of all of the slide I have. Most of the things that I've presented today have been sponsored by International Consortium for Antimicrobial Resistance, the POC board, and also Purdue and Fairfield. I think this is the end of my slide.
Fantastic. Thank you so much, Paul. That was great. And I really like the way that you put it, because it just takes stepping outside of your comfort zone to see that, oh, there is so much opportunity to do so many other things, interact with so many other people, learn new skills, and never stop learning, right?
Absolutely. Like, so initially when I saw this, when I had these opportunities to participate in this program, at the beginning, it's always, and I think one of the fears that we have is that stepping out of your comfort, trying to learn something new, it's always scary because nobody wants to do what they don't know. But if we keep on doing what we know, there's no opportunity for growth. It is only in learning what you don't know, in trying what you have never done before, that's when you have the opportunity for growth. So I always say that as a graduate student, it is absolutely vital that you step beyond your comfort, try the things that you don't know before, both in your research and other things outside of research.
Absolutely. And it's so it's okay to be bad at something when you first start doing it, right? Like it's perfectly fine. If you ask me, Tommy, speak Nigerian, let's start learning Nigerian, I probably would be pretty bad at it. Although, did I say your last name okay? Oladele?
I think, yeah, I think
There you go. Now we're getting somewhere,
that was
right?
very good. Yeah.
So, like, but it would be unreasonable for me to think, oh, I'm going to be very good at it. Just go with the expectation that it's going to be rough at the beginning, but the more you stick with it, the easier it gets, right?
Yes. So you study one time, it's not so good. It's probably very bad. It's probably not
Yes.
something you want to see again. But you try it, you do it the second time, it gets better. The third time, and before you know it, you become an expert. You become a professional that trains people. I remember when I first got to Dr. Tim Johnson's lab, when I first started doing microbiome science, I had no idea what I was doing, but now I mentor not just even undergraduate students, even graduate students. I get to mentor graduate students, teach them the rope of, okay, this is how this is done. This is what you need to do. This is how you do this. Oh, don't do this like that. I've had the, I have not, I wasn't trained a microbiologist, but now I do like almost every facet of microbiology. I do wet lab, culturing, I do like sequencing, computational work, and I still do in vivo animal work. And this is for somebody that has no idea at the beginning what I was doing.
I
So
love that. I
it goes
love
fast.
that. Well, thank you so much, Paul. This was a great, great opportunity to not only get to know more about your science in the microbiome field and in animal microbiome in particular, but also a little bit about your journey. And I'm so appreciative that you got to share with part with us as well. So thank you very much, Paul Oladele from Animal Sciences Department here at Purdue University. Thank you so much for providing that lecture today.
Thank you so much, Dr. Sauce.
Have a great day.
Thank you so much. Bye-bye.
Bye-bye. Thank you for watching the Purdue Lecture Hall series. Remember to hit the like button and subscribe to our channel.